Okay, 7.5, roots and zeros. What I want you guys to do real quick is solve both of these, and then I'll solve these two with you. So go ahead and try that real quick. You may want to just go ahead and pause the video. Okay, hopefully you saw that this is x equals -3. So what we would say here is that this is one negative real solution. All right, so then let's go over here and solve this one. Now, hopefully you saw that you could factor this down to x minus 4 times x minus 4 equals 0. And then you would have said, hey, well, that means that x equals 4, and you would have gotten the same thing here. So technically, this is two real solutions. Even though it's the same solution twice, it's still two real solutions. And it's two positive real solutions. So we would say the solution is x equals 4 with a multiplicity of 2, which just means this solution shows up 2 times. That's all that means. All right, let's do this other part. Solve this thing. We could factor out an x, and we would get x squared plus 2 equals 0, and then we could break this into two equations, x equals 0 and x squared plus 2 equals 0. The one on the left is already solved. The one on the right, though, we need to do a little algebra. And whenever we take the square root, we need to do plus or minus, so x equals plus or minus square root, and if there's a negative, we just pull an I out. I'll leave the 2 in there. So this one, we would say, has one real solution. We don't talk about whether it's positive or negative. And, okay, so we have one real solution and two imaginary solutions. There we go. Now for this one, it requires us to factor it a little bit. So we should see that this is really a perfect square and this is a perfect square. So we could break it down. X squared minus 1, x squared plus 1 equals 0. And then we still have a perfect square minus perfect square. So we could break this down to x minus 1, x plus 1. And this doesn't break down anymore, so we just leave it as x squared plus 1. And when we solve all of these, we see, hey, we got an x equals 1 here, we got an x equals -1 here. There's two of our solutions. This one takes a little bit of work. Take the square root of both sides, you get a plus or minus, you get x equals plus or minus, and the way you write the square root of -1 is just I. So for this one, we have one positive real solution, one negative real solution, and two imaginary solutions. Okay, so that was just kind of some review of negative solutions, positive solutions, and imaginary solutions, what they look like. Now what we're going to do is we're going to use this thing called Descartes' rule to determine what kind of solutions are possible. Over here in the column, I just give you some little pointers. I'll explain those as I go through here, but they're here just for your own reference. Okay, so all you have to do here is count the number of times the sign changes. That's the first step. So we went from positive to negative, that's 1, no change, another change, that's 2, another change 3, another change 4. So that means that we had 4 sign changes. So right away we can go down here to our chart. And this number gives us the number of real positive zeros. So we put a little 4 here. But there's also the possibility that it's less than this number, and it would be less than by 2, see? The number of sign changes is either equal to the number of positive real zeros or is less than this by an even number. So, meaning we just go down by 2s. So 4, 2, 0. All right? So those are our three possibilities of numbers of positive real zeros. To figure out the negative real zeros, we have to plug in negative x. I'm going to do it all below here. So we get negative x to the 5th minus 6, negative x to the 4th minus 3, negative x to the 3rd plus 7, negative x squared, minus 8, negative x plus 1. Anytime we raise a negative number to an odd exponent, the negative sign sticks. When we raise it to an even, the negative sign does not stick, so we just stay with the sign out here, which is already negative. The negative sign sticks, and this is already negative, so it becomes positive. Does not stick. Okay, now we count the number of sign changes. Doesn't change, does change, there's 1, negative, positive. Doesn't change, doesn't change, doesn't change. So, we only have 1 sign change there. This represents, because we plugged in a negative x, this is the number of negative real zeros. So we go over here, and we just say, hey, there's 1 negative real zero. Can we go down by 2? Well, that would be negative 1, which is not a possibility. So these are all just going to be 1 real zeros, negative real zeros. Now if we look up here, our total degree was 5. That means there's a total of 5 solutions. So here we're going to put a 5. To figure out how many imaginaries there could be, we just fill this in accurately. So 4 plus 0 plus 1 equals 5, 2 plus 2 plus 1 equals 5, and 0 plus 4 plus 1 equals 5. So our zeros is going to be one of these 3 possibilities. We don't know which one, but it's only one of these 3. And so this can help us in solving some problems. So let's do the same thing for this one. Let's count our number of sign changes. 1, 2, 3. Okay. So I'll make a little chart. Positives, negatives, imaginaries. They should add up to a total of whatever our degree is, which is 3. We know that there are at least 3 positives, and then we could go down, or we go down by 2. So 3 minus 2 is 1. So there's either 1 positive or 3 positives. Now let's figure out how many negative real solutions there are by plugging in a negative 1. We plug in a negative x, we get negative x cubed minus 4 negative x squared plus 6 negative x minus 4. So negative x cubed just turns into negative x cubed. Negative x squared, the negative doesn't stick, but it's already negative, so we just say negative 4x squared. Negative 6x, negative 4. The sign never changes, so that means the number of negative real solutions is 0. So that means that the number of imaginaries is either 0 or 2, because it has to add up to 3. So we're either all 3 are positive reals, or 1 is a positive real and 2 are imaginary. Since we know that we don't have any negative zeros, we can start looking for our zeros at positive 1 and just go up until we find it. We're going to use synthetic substitution until we find one of our positive real zeros. There's at least 1, maybe 3. Okay, so to do synthetic substitution, we just bring down the 1. And let's just start with the 1, and we'll move our way up. So 1 times 1 is 1. Added to negative 4 is negative 3. 1 times negative 3 is negative 3. Added to 6, it's 3. 1 times 3 is 3. Added to negative 4, negative 1. Okay, so that's not a 0. Let's try the 2. 1 times 2 is 2. Add to negative 4, that's negative 2. 2 times negative 2 is negative 4. Added to 6, that's 2. 2 times 2 is 4. 2 times 2 is 4. Added to negative 4, that's 0. We found it. We don't even have to keep going from here. So that means we could rewrite this function f of x with one of our factors, or one of our zeros, being x minus 2. Okay, so then in order to find out what the rest of it would be, we'd have to take this and divide it by x minus 2. Well, check it out. We already did that, and the answer is right here. That would be our x squared, that would be our x, and then this one would have no x. So let's write it in. X squared minus 2x plus 2. So to find the other two zeros, we're going to have to solve this somehow. Well, I would say first see if you could factor it. So you're going to say, is there something that multiplies up to 2 and adds up to negative 2? There is not. So we're not going to be able to factor it. So we're going to have to use the quadratic formula. So you're going to assume that this whole thing equals 0. Then you could use the quadratic formula, and you would say negative b is positive 2 plus or minus the square root. Your b squared is 4 minus 4 times your a, which is 1, times your c, which is 2, all over 2 times your a, which is just 1, so it's just 2. Simplify this down. You end up with 2 plus or minus 2i over 2. I'll let you work that out on your own if you want to see it. And then finally, you divide both terms by 2 and you get 1 plus or minus I. So we know that our solutions for 0, our zeros are when x equals 2 and when x equals 1 plus or minus I. So our little trick here up at the top, turns out that it worked. It was this, right? 1 real, 1 positive real, 0 negative reals, and 2 imaginaries. We knew it was going to be one of these two combinations, and it happened to be the second one. This told us where to look here. If we didn't know this, we would have had to look in literally twice as many places. We wouldn't even know where to begin to look. So that's why this little trick is really helpful. Okay. Now let's talk about the complex conjugates theorem. This just says that if you have a complex solution like a plus bi, then its conjugate, a minus bi, is also a 0. Okay? So, in example number 4, they tell us two of the zeros. It says, write a polynomial function of least degree with integral coefficients whose zeros include 3 and 2 minus I. So we know that one of the zeros is when x equals 3, one is when x equals 2 minus I. And according to this theorem, another one of the zeros is when x equals 2 plus I, because that's the conjugate. All right, now we have 3 zeros, we can begin to write a function. This is a factor of x minus 3. This is a factor of x minus 2 plus I. And this is a factor of x minus 2 minus I. Now, a little side note here. You may remember that if you had something like a plus, I'll just say I, and you multiplied it by a minus I, which is its conjugate, you would just, all you need to do really is a shortcut, is you just need to say, hey, that's just a squared minus I squared. That was the shortcut rule of conjugates. Well, in this situation, we're really doing the same thing, but you could think of x minus 2 and x minus 2 as your a. So we could write, if we were just multiplying these two things together, we could say, well, that's just going to be x minus 2 squared minus I squared. If you don't follow that, you can make a big box with 3 parts and 3 parts and multiply these two things together, and you're going to end up with the same thing we end up here. And then we still have this x minus 3 here being multiplied by this whole guy. So let's simplify this a little bit. We can use FOIL or the box method to simplify this down really quick, but we should get x squared minus 4x plus 4 minus, and I squared is actually a negative 1. So this is really x squared minus 4x plus 5, because that's a double negative. Multiply that by x minus 3. Okay, Now we're going to do the box, multiply this thing through. We get x cubed minus 4x squared plus 5x minus 3x squared, 12x, I don't know why I put a plus there, and minus 15. So our final answer is going to be x cubed. Then we have a common terms here, minus 7x squared, like terms here, so plus 17x minus 15. And there is our function that we were looking for. It said write a polynomial function with least degree with integral coefficients. That's it right there. We may just want to write y equals, but there we go. That's the function we're talking about. Now there may exist some function with these 3 zeros and another one, but that's not what we're concerned about. That's what they mean by least degree. So this is the least degree one. There could be some other function with another one, but we don't care about that one. All right, that's it for 7.5.